So how are we going to put this stuff into buffers? So let's take a look at points. So we're now in WebGL. We don't have this old style way where we have a GL begin and then vertex, 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 and then end. We're instead going to pack a bunch of data into an array, which it already was stored in an array here, right? We were looking up each element and calling vertex for each element. So we're going to pack all this stuff into an array. We're going to make some calls, which are going to pass this data over to be an attribute variable that lives on the GPU. So this is now on the GPU. And then when we call draw arrays, this is a piece of JavaScript code. When we call draw arrays and tell it to use points and to please render the points from 0 to n, what is it going to do? It's going to treat these first two things in the array, right? Because these are just elements in the array as the first point. And then, okay, well, point 0, and then point 1, and then point 2. And we're going to go down the list and draw each one like this. This is because we specified points. Now, given exactly the same array, I'm not going to change the array. I've already passed it over to the GPU. I'm just going to make a different call. So now I'm making a call to draw arrays with GL lines instead of points. So I haven't changed what I've already passed, what's already sitting in this buffer on the GPU. It's now going to interpret it differently. It's now going to take these first 4 items and create this line, and then take this next set of items and create this line, because I've specified it as lines. If I specified strips or loops, it would choose a different set of how to choose what is making into lines. Same thing, we're going to keep exactly the same array buffer that we passed across. So now if we want triangles, okay, now we're specifying triangles. There's only 1/3 of them. And we're going to take the first 3 vertices, and we're going to create a triangle out of this. And then we're going to take the next 3 vertices and create a triangle out of this. So when we call draw arrays, we tell it how to interpret the buffer that we've sent across. So this buffer that we've sent across stays constant. And what's changing is the way we interpret it according to how we call in our draw arrays command. So there's something a little confusing here. So I previously showed this slide last time, and I said that we send the buffer. So here's our buffer sitting on the GPU, right? This is stuff running in JavaScript. And then I said we take the first item and we run the shader, and then we take the next item and run the shader. So, but here I said we have a whole triangle. So this is not quite right. There is a whole triangle here that's getting interpreted and drawn, but in terms of your shaders, this is correct. The shader gets the information for the first vertex and runs, and then outputs to the later stages. And this running of each vertex is exactly the same, whether is it points, lines, or triangles, because each vertex is processed entirely independently. So let me draw a picture of this. If we're doing a triangle, we're first going to take this first vertex, run our shader, and then take the next vertex and run our shader on it, and then take the next vertex and run our shader on it. So the vertex shader is not caring as its points are triangles. Now, after the vertex shader and before we get to the fragment shader, there's an assembly step that has to decide how to interpret. Am I dealing with points? Am I dealing with lines? Am I dealing with triangles? Which pixels should I turn on? So that step, which is deciding to turn on these intermediate pixels, is what's getting changed by this triangle. So we're going to come back to that in a little bit. Now, there's a different way we could store buffers. So I think it's worth talking about because it's worth understanding the ways that we can use buffers. So we've so far talked about a buffer, which is a very linear kind of thing. We store our vertices into it. For very large objects, is sometimes not as efficient because see this vertex 2, suppose I was specifying it as triangles, not strips. Vertex 2 here is getting used in 2 different triangles. Or down here, vertex 0 is getting used in a lot of triangles. And I might want to not have to send it across the bus to the GPU every single time. So a more efficient way to store things is to make a list of all the vertices. So here's a cube, and we have vertex 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's our vertices, right, that are stored on this cube. And see, they have a vertex here in the middle. I was wondering why is there more than 8 vertices, because they've got one drawn here in the middle and they're putting some extra triangles. Okay, this is okay. You store your vertices wherever you want to. And then we have a face list. And for each face, meaning each triangle, we index which vertex we want to use. So for face 0, that's this face here, we're going to use vertex 5, 4, and 0. Okay, here they are, 0, 4, 5. Okay, they've got them in a different order. Here they are, 0, 4, 5. And for face, let's go over here to face 3. We're going to want 1, 6, 2. Here's face 3, 1, 6, 2. So we have an indexing lookup. Now, what's the advantage here? Right now, we're only storing positions in our vertex list. Ignore this part. This is a backwards link that tells for each vertex to the face. This doesn't exist in OpenGL or WebGL. We only store this vertex buffer, which goes into the array buffer, and then we have an elements buffer. So there's two different buffers we can fill. We can fill this buffer, and then we fill this indexing pointer method of figuring out the triangles into another buffer. If we do that, instead of calling draw arrays, we call draw elements. So the book talks about this if you want to know more about it. It can be useful for larger objects. Because there's a level of indirection here, I find that when I suggest students to do it, I get a lot more people in office hours with bugs. Why? Because maybe they filled this up correctly, but then they have the wrong pointer to the wrong place. Or maybe they got a wrong vertex here because they're trying to share it across things. And so then one triangle is working, but the other triangle is not working. Or some other kind of thing. Because there's a level of indirection, I think it makes things harder. So therefore, for this class, I recommend you use draw arrays, not draw elements. However, you can do it, and I've had students in past classes do it. And if you're having no trouble with the assignments, you might want to go investigate it and see whether it makes things more efficient for you. So why would I ever do this? Well, I said there's a little efficiency gain. I don't have to store all these vertices. And right now we only have positions, but in the future we might have normals and UV coordinates and colors and textures and other things attached to each vertex. So the amount of data in each vertex might be higher, and it might make more sense. Another reason is because file formats are that way. So there's a lot of different formats for storing 3D geometry. You may have heard of some of these. So OBJ is quite well known. You can find lots of stuff on the web. PLY is more used for academics. So a lot of research papers and universities use PLY for storing stuff, although it has some commercial usage. But let's take a look at what's in one of these files. So this is a PLY file. It's often stored as binary, but here I've got it split out into ASCII so we can see. So we have some stuff that tells us we're in apply format. And then we say we're going to have 12,500 vertices, and they're going to be stored as X, Y, Z. And then we're going to have 25,000 faces, meaning triangles, and they're going to be stored as a property list with the indices, right? And then we get to the end of our header. So here's our vertices. There's going to be 12,500 lines of this, X, Y, Z, X, Y, Z, X, Y, Z. These are all the vertices. And then when we get down here to line, we started on 10 here, right? 12,510. Now it's time to start talking about triangles. So this was defined at a time when it was still okay to use polygons. So we say that there's going to be 3 vertices. And the vertex numbers are vertex 6280, 6318, 6403. So this is exactly the same format that we were talking about here. So some file formats store this way. So if you wanted to load those files, it might be more convenient to just load the data and then to render directly, rather than go back and reconstruct all the triangles and pack them into a new set of arrays. So this is another reason you might use elements if you were trying to read files to get more complicated pictures. Okay, questions about how this data is going into buffers. Right, so we talked about points, lines, triangles, how we pack these things into buffers. Where does it flow through to the shaders, this drawing elements way? Okay, so which one should you use? You should use draw arrays. This is the one that I recommend that you use. And if you follow my walkthrough on assignment 1, which is in the YouTube, it's going to walk you through using draw arrays. That said, there's no right. The book is going to talk about both. Indeed, somewhere in the book, it defines how to make a cube using draw elements. I'm going to try to lead you a different way to do it because I think it will lead to fewer bugs, but there's no right answer about the right way to do it. Okay, yeah, draw arrays is crossed out here because this picture, this is the change that was made. I agree, that's confusing in the slide. In this, if you specify this way, you use draw elements. You don't use draw arrays. Any other questions?